Hey, fourth year, if you're seeing this, this means that you have chosen formula and reacting quantities, which basically means you either don't know how to write a chemical formula or you're struggling with some of the more basic calculations. Great, let's go through it quickly. Okay, feel free to pause at any point so you can read the slide. I am going to talk pretty fast to try and keep the length of the video down. So feel free to go back, rewind it and rewind. Okay, that made me sound old. Go back and take the video back to any point that you want so you can listen to it over and over again. Okay, so naming compounds. Names of elements come from the names of compounds come from the element they contain. So if something ends in IDE, it contains only the elements in the name. So magnesium oxide contains magnesium and oxygen. Sodium chloride contains sodium and chlorine. Okay. If it ends in ate or ite, it also contains oxygen, which means that if we're thinking forward to formula, it's a group ion. So sodium carbonate contains sodium, carbon, and oxygen. Okay. Calcium nitrate, calcium, nitrogen, and oxygen. Okay. Keep that in your head because it's going to help you later on when you look at formula. So remember the process to working out formula is SVSDF. Symbol, valency, swap, divide. Remember that my mind's gone blank. Yeah, remember that valency is the number of bonds that an atom can make and it's related to its group number. So group 1 has a valency of 1, group 2 has a valency of 2, group 3 has a valency of 3, and group 4 has a valency of 4. Then it starts going back down the way. Group 5 has a valency of 3, 6, 2, 7, 1, and group 0 has a valency of 0 because it's a noble gas, it can't make any bonds. Okay. Once you've done that, swap them over and then try and divide by the smallest number or simplify the ratio. So if it's 2 to 4, that can be simplified to 1 to 2. Okay. Remember that if it's a transition metal, so if it's in that block in the middle of the periodic table, they can change their valency. So copper can be copper 1, copper 2, copper 3, or copper 4. You don't need to know which one it is. The name will tell you using Roman numerals. So remember, I is 1, I is 2, I is 3, IV, did I say that the right way? IV is 4, V is 5. Okay. Remember that because if it's a transition metal, they will give you the valency in Roman numerals. Okay. Prefixes. If it is a prefix, you need to ignore everything I just said and just read the prefix. So carbon dioxide, CO2. The biggest mistake people make is that they see the prefix and they think, great, that's the valency, let's swap. So they end up with the answer C2O. That's not the case. The prefix literally tells you the number of atoms. So carbon dioxide, carbon 1, no prefix, dioxide, 2 oxygens, O2. Carbon monoxide, carbon 1, monoxide, 1 oxygen, CO. Okay? Ions containing more than one type of atom are group ions. Okay, so if you're looking at the ites or the eights, remember that that's a group ion. You can find them on page 8 of your data booklet. You do not need to remember the formula of all of those. And remember the valency is the charge at the top of the table. So it gives you a list of all the 1 negative group ions. It gives you a list of all the 2 negative group ions. Sorry, I got hiccups. It gives you a list of all the 3 negative group ions. The number is the valency. So if it's in the 3 negative group ions, it's got a valency of 3. Nitrate, which you can see here, is in the 1 negative column, which is why they've given it a valency of 1. I would always put brackets around these because the chances are you're going to have more than 1. So this case, there is more than 1 nitrate. If you don't have those brackets in, what it looks like you have written is CaNO32. That's why the brackets are important to tell you that the 2 applies to the whole group ion, not just the oxygen. Remember that ionic formula, you can put the charges in. Remember, charges stay. That's why I tell people to put the charges in here. So Ca2 plus, NO minus, and keep them there. Do not swap the charges over. Valency swaps, charges don't. Okay? Chemical equations can be written and balanced to represent chemical reactions. So copper plus oxygen, copper 2 oxide. Copper is Cu. Remember, oxygen is diatomic, so that gives you O2. Copper 2 oxide, once you work out the formula of that, so Cu, O, it's got a 2 and a 2. Remember, it's 2. Copper is 2 because it tells you in the name. Swap them over, divide gives you CuO. And then you can balance it to make sure that the number of atoms are the same on either side. Okay. Yeah. Getting into some of the calculations, remember the mass of a mole of a substance in grams is equal to the gram formula mass and is calculated using the relative atomic mass. A mole is just a number, okay? A mole is just a certain number of atoms or molecules. You don't need to know what that number is. However, 1 mole of one substance will have the same molecules as 1 mole of another substance. That's how we can then compare the masses of the molecules. Okay, because if you've got, I'm going to say it's 10 molecules, it's not. It's a ridiculously large number that I can't even get my head round. But let's say it's 10. So you get 10 molecules of oxygen versus 10 molecules of carbon dioxide. You can then say which one's heavier because the mass of 1 mole is 16 for oxygen, where it is. So it would be 32 because it's O2 because it's diatomic. Please remember diatomics and don't do what I just did. Or it will be 32 plus 12, 44 for carbon dioxide. Okay. Remember that the brackets inside and outside the bracket multiply to give you 12 times 1 equals 12. 3 times 14 equals 42. Okay, so 3 times the mass of nitrogen, which is 14, and it's 12 times the mass of hydrogen, which is 1. Add that together, or add that all together gives you the relative atomic mass. What you can then do is use this triangle to work out the mass of a substance or the number of moles that you have using the GFM. Either way, cover up the one that you're trying to work out. So if you're working out the mass of a substance and you know the number of moles and you know the gram formula mass, cover up N. I literally just tried to cover up the screen there. None of you saw that. Ignore it. Cover up N and it gives you N times GFM. Okay. If you cover up N, if you're trying to work out the number of moles that you actually have, cover up N and it gives you M divided by GFM. Okay. That's how these triangles work. The formula is at the front of your data booklet. The triangle isn't. So if you want to use the triangle method, you'll need to remember that triangle. Okay. Calculating the mass from an equation. Okay. I'm literally gonna skip that slide because they teach it in a way that I don't teach it. If you get to calculations from a balanced equations question and you don't understand how to do it, give me a shout. Okay, and I might start a Teams call so that people can jump on and I'll do a couple of examples. Let me know. Okay. A solution is formed when a solute is dissolved in a solvent. This is then done in the exact same way. If you have the number of moles of a solution and you have the concentration, you can work out the volume by covering up V and it gives you N over C. If you want to know the concentration, cover up C and it gives you N over V. Okay, etc., etc. Okay. Percentage composition, we don't cover in this topic. It's covered in the fertilizers topic, but it's always good to go over. So remember, percentage by mass equals the mass of the element you're looking for divided by the GFM of the full molecule times 100. So calculate the percentage of nitrogen and ammonium nitrate, NH4, NO3. Calculating the mass of nitrogen, remember there's 2 nitrogens, there's one here and one here, so therefore the mass will be 28, not 14. And the full GFM is 80, so it becomes 28 divided by 80 times 100 gives you 35%. Okay, that was a lot of information in a very short amount of time. Go try the mind map. If you need to flick back through this video, you can do that. Use your notes, use every bit of revision material you can think of, BBC Bite Size, to get this topic in your head. Remember, calculations from balanced equations, let me know if you need help. Okay, thanks guys. And I'll see you all in the Kahoot at the end of the lesson. Bye.